Hello friends, have you ever wondered how a small uranium pellet, which is just the size of a peanut, can be so powerful that it alone can provide electricity to thousands of homes for an entire year? Can such a small thing really hide such dangerous energy inside it? And if I tell you that behind achieving this energy lies a process that is one of the most complex and dangerous processes in the world, would you believe it? Because today, we are going to take you to a hidden world where an ordinary-looking stone taken from inside the earth is passed through many high-tech machines, dangerous chemicals, and extreme conditions to create nuclear fuel. Where every step requires precision, every process has control, and every small mistake can become the cause of a major danger. So let's know the full truth of enriched uranium, from its journey hidden beneath the ground to the nuclear reactor. First, let's go back in time a little. The year was 1789, when a German scientist, Martin Heinrich Klaproth, first identified uranium as a chemical element. At that time, it was considered just an ordinary metal. No one had any idea that such dangerous power was hidden inside it. Then, for many years, it remained just a scientific curiosity. But the real change came in 1896, when French physicist Henri Becquerel discovered a strange phenomenon. He found that uranium emits radiation on its own without any external energy. And from here, the world of radioactivity began. After this, Marie Curie and Pierre Curie took this research forward and discovered new radioactive elements like radium and polonium. Gradually, scientists began to understand that a hidden world of energy exists inside matter, which, if controlled, could change the entire world. Then came another big turning point in 1932, when James Chadwick discovered the neutron. This was a subatomic particle that had no electric charge, but its power was immense. And this neutron later became the key to nuclear fission. A few years later, in 1938, German scientists Otto Hahn and Fritz Strassmann conducted an experiment. They found that when neutrons are fired at uranium atoms, the atoms split apart and release a huge amount of energy. This phenomenon was called nuclear fission, and from here began the real story of nuclear energy. Now understand one important thing. Natural uranium is not all the same. It has two main isotopes. First, uranium-238, which is about 99.3%, and second, uranium-235, which is only about 0.7%. But the isotope that actually does the work is uranium-235, because it undergoes fission easily, whereas uranium-238 mostly remains stable. That means if we want energy, we must increase the amount of uranium-235, and this process is called uranium enrichment. Now imagine the time of World War II, when the entire world was at war. During this time, the United States started a secret project called the Manhattan Project, where the world's greatest scientists worked together. Their goal was to enrich uranium to create a weapon of unimaginable power. Scientists like Enrico Fermi and Robert Oppenheimer played key roles in this project. They developed techniques to separate uranium isotopes, such as gaseous diffusion and centrifuge technology. The result of this research was the atomic bomb that shook the entire world. But after this, the focus shifted from destruction to electricity generation. In nuclear power plants, uranium is enriched only up to about 3 to 5%, so that energy can be produced in a controlled way. Whereas for weapons, enrichment levels can exceed 90%. That is why uranium enrichment remains one of the most sensitive technologies in the world. Now the question is, where does uranium come from? It is found deep inside the earth in a mineral called uraninite, usually in very low concentrations. But in some places like Canada's Saskatchewan region, the uranium concentration can be extremely high. However, mining here is not easy because of water-filled layers above the ore. To solve this problem, engineers use a technique called artificial ground freezing. In this process, extremely cold liquid is circulated through pipes drilled into the ground, freezing the surrounding water and soil into a solid ice wall. This ice wall prevents flooding and allows safe mining. Then begins the extraction process. Large drilling machines break the rock and the ore is collected and brought to the surface. The entire operation is controlled remotely to keep workers safe. The ore is then crushed, ground into fine powder, and mixed with water to form a slurry. This slurry is transported to a processing plant where chemicals are used to extract and purify uranium. Next comes the most critical step, enrichment. Uranium is converted into a gas called uranium hexafluoride and fed into high-speed centrifuges. These machines spin rapidly, separating heavier uranium-238 from lighter uranium-235. This process is repeated thousands of times to gradually increase the concentration of uranium-235. Once enriched, the uranium is converted into powder and processed into uranium dioxide. It is then compressed into small cylindrical pellets. These pellets are incredibly powerful despite their small size. They are heated to increase strength and then placed inside zirconium tubes to form fuel rods. Multiple fuel rods are assembled together and installed inside a nuclear reactor. Inside the reactor, uranium-235 atoms split when struck by neutrons. This process, called nuclear fission, releases heat and more neutrons, creating a controlled chain reaction. The heat turns water into steam, which spins turbines connected to generators. This is how electricity is produced for millions of people. However, after use, the fuel becomes highly radioactive and must be stored carefully. It is placed in deep cooling pools for several years to reduce heat and radiation. Even after spending years inside cooling pools, these spent fuel rods are still highly radioactive and must be handled with extreme care. In many cases, they are transferred to specially designed dry storage containers made of thick steel and concrete. These containers are built to safely store nuclear waste for decades without leaking radiation into the environment. Scientists around the world are continuously working on advanced technologies to recycle and reuse nuclear fuel, reducing waste and increasing efficiency. So next time you switch on a light, remember the complex science and engineering behind it. This journey of uranium is not just a process, but a powerful example of human intelligence and innovation. If you enjoyed this video, make sure to like, comment, and share your thoughts. Also, tell us which topic you want next. And don't forget to subscribe for more such informative and powerful content.